Hello and welcome back to another episode of How to Do That. Today we are going to be discussing Ohm's law and why it is very important to understand this when creating your own circuits. So to start off, what is Ohm's law and why is it important? Ohm's law is actually very simple to state, but a bit more complicated to understand. So Ohm's law, just to write it out, is current, which is I, equals voltage divided by resistance. Now, those of you out there that have had a science class, you're screaming right now, Ohm's law is voltage equals current times resistance. It's actually not. It is actually current equals voltage divided by resistance. Now, the reason that this is important is because we see three things here. Current is independent of voltage and resistance. So by knowing any two of these quantities, we can calculate a third. And it is easy to figure out what these other relations are. So for instance, solving for V, we get voltage equals current times resistance. Or we could solve for resistance. Resistance equals voltage divided by current. Now, voltage is measured in volts, as you would think. Current is measured in amps. I'll actually just write that here beside of it. Voltage in amps. And resistance, if you have seen the other video on this channel talking about resistor codes, you know the resistance is measured in ohms. OHMS. So, what does this matter? What does this really mean in terms of circuits? Well, to understand that, we first need to back up and understand what electricity even is. And I've actually printed off an excerpt from the Arduino Starter Kit Projects book. This is on page 22 of the current version relative to when this video is published. And it had a really good example in it. So it gives an example of a rock slide. And it says that you have a mountain, okay? And the mountain is of a certain height, okay? That height is voltage. And the reason that it's represented as voltage is because there is another term for voltage, and that is potential difference. Now, the reason that this term is more relevant here is that potential difference sounds a lot like potential energy when you're talking about physical objects falling from a high point to a low point. Voltage is, as a metaphor, the same thing. So you have some type of potential difference between 2 points in a circuit, and because of this potential difference, you get a flow occurring. What's flowing exactly? Well, let's talk about that. So in a rock slide, it's not a rock slide without rocks, right? So we have rocks here represented by these shapes here, and that is your current. Now, current is the amount, you can think of it as the amount of electricity flowing down this potential difference. So the voltage creates an environment where a flow can happen. The current is the actual quantity of that flow. So in this case, the amount of rocks coming down the mountain. Now, obviously, the mountain is not frictionless. It's not free of obstructions. So there are, looks like little trees here. This is resistance. So this is resistance to the flow of the current, to the electrical flow. So depending on how many bushes you have, or how many trees, or how many whatevers you have, this will slow the rate of this current. Okay, so it's going to slow the electrical flow. Now, the rocks are going to get from here to here, factually. That's going to happen. But the question is, how fast is that flow? How much flow is actually going to be able to get through and get to the bottom? And that's what resistance is here, are these bushes, these trees that actually prevent the flow from coming down. So it's kind of a loose metaphor, but it's one that kind of gets you in the ballpark of understanding how voltage, current, and resistance is related. And notice that these, voltage, current, and resistance, are the same things that we talked about up here in Ohm's law. So we know that the current is going to equal the voltage divided by the resistance. They're all independent, but they're all related. So if all you want is the overall explanation of Ohm's law and you don't want to get any more mathematical than this, please skip ahead to the timestamp on your screen. If you remain though, I'm going to explain a little bit more in mathematical terms what all of this means. Okay, so if you stuck around this far, you can actually think of resistance as a constant in Ohm's law. And in fact, inside of Ohm's law, resistance is defined as a constant. So I know earlier I was talking about all of them are independent. I wasn't really talking about mathematically independent. That was it's just something to better understand how these three are related. But in Ohm's law, resistance is treated as a constant with I and V being the true independent variables. And because of that, this relation here actually is fairly similar to an equation for a line in y-intercept form. So recall back to, high school algebra or even middle school. Y equals mx plus b, with y and x being the axes of your graph. So this would be x and this would be y. Now, a line like this is just a straight line, and we're going to kind of simplify things here and just assume that we're dealing with straight lines. There are things called non-ohmic materials that actually do not follow Ohm's law. Those are actually common things like batteries and diodes. But to keep it simple, and the fact that you can use this in a circuit where those things are being used, we're just going to talk about Ohm's law face value. We're not going to get into the exceptions. Y equals mx plus b. Now, let's just assume that b is 0, okay, which means that our line is going to go through the origin. We can actually relate y to be I, m is 1 over r, and x is v. If we do this, we know that 1 over r is our slope, I is current, and v is x down here, which is our volts. So doing this, we can actually draw this line where this slope here is 1 over r. Now, so this is a more mathematical way to think about what's happening here, to where you have this resistance constant, and you really can think of it as constant in a vast majority of cases because you're only putting in resistors, or you're setting a value for some type of variable resistor and you're keeping it there. You can assume that being the constant, and you have your line here to where if you know a certain voltage, say your voltage here is here is what you've measured. You go up to here where that collides with the line, go over to there. That's going to be the current you can expect flowing through that component. So that is the more mathematical background of Ohm's law. So now let's look at an example of how to use Ohm's law and why it's relevant. Okay, so the example I'm going to be using is actually on page 30 of the Arduino Starter Kit Projects book. It gives a very, very relevant example to the first tutorial in that book, and if you haven't seen that video on this channel, please go and check that out now. It's a really good tutorial that lets you see the difference between series circuits and parallel circuits, and it's a pretty good circuit to get started with. But in this example on page 30, it actually gives an example of the resistor that we were using in that tutorial. So let's assume that you are supplying 5 volts, which is exactly what we were doing in that tutorial. So the voltage is 5 volts. Now, we had in that circuit a resistor that was a 220 ohm resistor. So our R equals 220 ohms. The question is, what is the current flowing through that circuit? Now, let's just keep it simple and talk about the basic circuit that we did in that tutorial. So the current going through that resistor is I equals V over R. Solving, that's 5 volts over 220 ohms, and that equals 0.023 amps. There is another term for this. If you've watched my resistor codes video, you'll know that we follow the metric prefixes for a lot of these units. So 0.023 amps is 23 thousandths of an amp, and a thousandth in metric is milli, M-I-L-L-I. So this can also be written as 23 milliamps, just like that. So that's how much current is going through the resistor. Now, every component in a circuit is going to have some type of rated current and voltage, may have it written in watts. It's going to have some type of characteristic limit for those components. And so you always want to be sure what the current is flowing through a component. What is the voltage flowing through a component? Right now it's really simple because we're doing very simple circuits, so everything has 5 volts going through it. But later on we'll have to use something called Kirchhoff's law, that when we have more complicated circuits, the voltages will get divvied up. We'll have to figure out what's happening to our current. It's going to be a lot more complicated, so it's good to understand the simpler cases like this of how to use one of these 3 relations here in order to solve what we're wanting, which in this case is current. Now, the 23 milliamps of current going through resistor really isn't a big deal. Where it's a big deal, though, is the LED. The LED that is supplied in the starter kit, I believe, I actually haven't checked this, I probably should have checked this, but I believe around 25 milliamps is its limit. If you get much further past that, you're going to shorten the life of the LED, so you always want to be sure that you understand what current, what voltage is going through your circuit at any time. So like I said, the LED limit is 25 milliamps. And because 23 is less than 25, we know we're good, okay? But this is something that when you're making your own circuits, you will actually want to go through and calculate what the current is across different parts, what the voltage is. So you can do that with something called a multimeter, and that will be another video later on of how to use a multimeter. There are some gotchas. For instance, you cannot measure voltage in the same way that you can measure current. So there are some things like that I would love to give you tips about. But for right now, that is Ohm's law. That is also how to apply it. Hopefully that helps. Please let me know in the comments below if that video helped you, or if you have any other suggestions for anything in the electronics theory playlist that this video is actually in. And please check out the other videos in that playlist. As always, please like and subscribe if it helped you. There will be other videos going forward. And being able to subscribe now early on allows you to kind of help give ideas for the channel direction as we go along. So with that, thank you very much for watching, and until next time, see ya.